Hello dear children, it's Naziya Ustad here with part 3 of motion chapter. In this video, you will learn about speed, velocity and acceleration. How do we know whether an object in motion is traveling faster or slower than another object? Consider two objects both moving along the same path. Just by looking at their motion, can you tell me that which one of them is moving faster? Clearly, this one is moving faster. In comparison to object 1, object 2 keeps lagging behind. Hence, we say speed of object 1 is more than the speed of object 2. Speed is that physical quantity which tells us how fast something is moving. How do we define it? In order to know the speed of an object, there are just two things we need to know. First, the distance traveled by an object in motion, and second, the time it takes to complete that distance. Consider a car moving on a straight road. First of all, can you tell the type of motion which it is undergoing? Since it's moving in a straight line, it's in a rectilinear motion. Suppose the time interval it takes to reach the other side is 30 seconds. Now consider another car which is similar to the first one, which is also moving in a straight line path chasing to the first one. The time taken by this red car to cover the same length of this first road is 40 seconds. The blue car covers the path length in 30 seconds while the red car covers the same path length in 40 seconds. Which one of them is moving with a greater speed? By intuition, we can say that the blue colored car was traveling at a greater speed than the red one. Why? Because the blue colored car covered the same distance in lesser time. Let the length of this path be 420 meters. This path length is nothing but the distance that the car travels in a given amount of time. Now for an object, if we take the ratio of the total distance covered and the time required to cover that distance, we will get this. This ratio is called the speed of the object. Yes, speed is distance over time. Since this ratio is greater than this one, it means that the blue colored car traveled with greater speed. Let's bring in a white car, which covers the same distance in 20 seconds. So what is its speed then? The speed is 420 meters by 20 seconds, which will give us 21 meters per second. And you can say that this ratio is greatest of all. Now I wanted to look at its units. Meter per second is one of its units of speed. There are many such units of speed that you must be aware of. For example, kilometer per hour, miles per hour, and feet per minute, and so on. Let's discuss something interesting now. Look at the example one of the cars. Say car A. The only information that I give you that it covers 420 meters in 30 seconds. That gives us the speed of 14 meters per second. I wanted to answer the next question that I am going to ask you. In this example, can we say that the speed of the car is constant throughout this distance? Or we say that the car is covering 14 meters every second throughout the path? No, that's not what we are implying. Because maybe the car is moving with really fast speed initially and then it slows down in the middle of and it stops and then again speeds up. So this speed does not imply that the speed is constant at 14 meters per second throughout. So what is the speed then? The speed we calculated here is average speed. In fact, in all the three examples, it was average speed. How do we define it? Average speed is defined as the total distance traveled by an object divided by the total time taken. We have seen previously that speed is the amount of distance covered in a given amount of time. It's nothing but distance covered over the time taken to cover the distance. Simply put, it tells how fast an object moves. Also, if we know the speed and time taken to cover a distance, we can easily find the distance covered. So, if I tell you that I traveled at a speed of 50 meters per second for 1 minute, can you tell me that how much distance I covered? Tell me. I'm sure that you have come up with the answer. I have covered a total distance of 3000 meters. But if I cover 3000 meters from this point, am I here or over there? You had no clues as to which direction I headed off. This tells us something interesting. Speed offers only the magnitude, making it what we call in physics a scalar quantity. It doesn't specify the direction. It just tells how much distance is covered in unit time regardless of direction traveled. Scalar quantity have only magnitude and do not specify direction. Do you remember the difference between distance and displacement? Distance just tells us the distance covered, but displacement is the distance with the direction. Say the distance between town A and B is 20 kilometers. So if we take a 50 kilometers route from point A to B like this, the distance covered is 50 kilometers and displacement is 20 kilometers north of point A. So speed doesn't tell us the direction. Is there anything that tells us the speed along with the direction? Yes, it's velocity, which can be written as lowercase v. Let's see how it differs from speed. What if I tell you that I travel north at a speed of 50 kilometers per second for 1 minute? You would be able to tell me where I landed up? Yes, you would know I have covered a total distance of 3000 meters and landed up at this point. Velocity is speed with the direction of motion. As such, velocity is direction aware. So, when you mention velocity, you must keep track of direction. Something like the car moved south at 55 miles per hour. If you do not mention the direction and just say the car moved at 55 miles per hour, you are not stating the velocity anymore. What you are stating is speed. What do you think is the unit of measurement of velocity? The unit of measurement of velocity is just like speed is meters per second. Now you might ask, why meters per second? The cars we drive indicate speed in miles per hour or kilometers per hour. So why is the unit for velocity meters per second? The established SI unit for measurement of velocity is meters per second, and SI stands for International System of Units. This helps everyone in the world to adhere to one common style of measurement. Imagine the confusion created with the different measurements like miles and kilometers, gallons and liters, US gallons and imperial gallons, etc. Incidentally, speed and velocity are both measured in meters per second. But do you remember which one is scalar quantity and which one is a vector quantity? Yes, speed is a scalar quantity and the velocity is a vector quantity as the direction is specified. Now let me ask an interesting question. What is the average velocity? To make it a bit easier for you, let's look at the example we looked at in our first video of motion. You have to travel 20 kilometers up north, but because of the roadworks, you took an alternate path which totaled 50 kilometers, and you took 2 hours to reach the destination. This was your path of travel. Let's make me 2 columns here, one for average speed and another for average velocity. Do you remember how we calculated average speed? Yes, it is the total distance covered over the total time taken. So 50 over 2 will give us 25 kilometers per hour as the average speed. Now what will be the average velocity here? The average velocity depends only on the start and end points, regardless of the path taken. Do you remember we had learned about displacement? So the average velocity equals to displacement over time. What is the displacement here? It's 20 kilometers up north. Distance with the direction. So the average velocity will equal to 20 kilometers over 2 hours, which will equal to 10 kilometers per hour. That's the concept of average velocity. So if you think you have really understood this concept, here is a question for you. You are a Formula 1 race car driver. You had a great race and finished the 300 kilometers race in 1 hour and 40 minutes at number 1 position. What was your average velocity? Tell me. Okay, if you didn't get it, let me give you a hint. This was your start point and finish line as well. They were both the same. You went around the track several times only to eventually finish at the same point where you started. So tell me now, what was your average velocity? Tell me. First, can you tell me what was your displacement? You started and finished at the same point, so your displacement is 0. 0 divided by the time taken, which is 1 hour 40 minutes, equals to 0. That puts your average velocity for the race today at 0 meters per second. If, however, you are trying to calculate the speed you drove at, that would be a different answer. Try and work it out. When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat, and when brakes are applied, we get pushed ahead, or when we take a sharp right turn, we are pushed towards the left. These are all situations where we are accelerating. We have all experienced this whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you 2 examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers per hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers per hour. In which case do you think acceleration is involved? Think? None. In both the cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's a speed with a direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers per hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers per hour and then it moves right at 30 kilometers per hour and continues traveling at the same speed of 30 kilometers per hour. Will there be acceleration in this case? The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed. But the velocity changes as the direction changes. So, this was the most important concept you had to know about acceleration. It will exist only when there is change in velocity. But how acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of formula, acceleration can be written as change in velocity over time. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t. Say this object at rest initially at point A. It then travels to the right and attains the velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken is 5 seconds. Hence, the acceleration a will be equal to 10 meters per second minus 0 meters per second divided by 5 seconds. So, this will be equal to 10 meters per second divided by 5 seconds. 10 over 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a unit by looking at this. The units of acceleration will be meters per second square. Because it's the change in velocity over the time taken. As this meters per second, we can carry this seconds to denominator, and what we'll get is meters per second square. This one is more intuitive, but this one is a bit neater, I would say. So acceleration in this case will be 2 meters per second square, and acceleration is also a vector quantity. Here acceleration and velocity are in the same direction. Dear children, here I would like to wind up this video, and further concepts will be learned in the next video. Thank you.